So today we're going to be finding x-intercepts for linear equations, so lines, and also quadratic equations, parabolas. So here, for number 1, I have y is equal to 2x minus 4. Now if I graph this, and I want to find the x-intercept where it crosses the x-axis, I can see it's right here when x is 2. So that's helpful. But what if I wanted to solve this without a graph? And I wanted to solve this algebraically. Well, notice on the y-axis, here y is 2, y is 1. Y is negative 1, y is 2. All along the x-axis, y is equal to 0. So if we take y and we set it equal to 0, we're going to find out where the x-intercept is by solving for x. So I add 4 to both sides, so I get 4 is equal to 2x, divide by 2, so I get x is equal to 2. Now this is a point, so I'm not going to leave my answer as x equals 2. I'm going to actually write this as 2, comma 0. Again, because y is 0, the x value I found is 2. Now over here, even if I do graph this, this is between 0 and 1 somewhere. Maybe it's a half, but maybe not. I don't know exactly where that is, and I can't tell based off this graph. So this is where solving algebraically is going to be the best method. Again, the x-axis is y0, so if I make y0, I set 0 is equal to negative 7 over 2x plus 2. Now, one nice trick here is I don't like working with fractions. So I see that I have a denominator of 2, so I'm going to basically multiply the entire equation by 2. So 0 times 2 is still 0. Negative 7 halves times 2, well, the 2's cancel out, so I'm left with negative 7x, and then 2 times 2 is 4. If I subtract 4 from both sides, I get negative 4 is equal to negative 7x. If I divide negative 7 from both sides, I get that x is equal to 4/7. Now, would you be able to tell that from this graph? No. So, again, I write my point as x being 4/7 and y being 0. And this is very, very important. So, with lines, it's real simple. You make y 0, you solve for x. Sometimes you have fractions, it can be a little bit complicated, but that's it. With parabolas, it's a little bit more difficult. Now, we've looked at factoring quadratics and factoring before, so if you need more review with that, go check that out. But here, hopefully we can see that we can factor this. Now, if I graph this, again, I can see it crosses the x-axis at 1 and at 4. But sometimes it's not always that simple. So if I set this equal to 0, I get 0 is equal to x squared minus 5x plus 4. How can we solve this? I can't just subtract the 4 because then I have two separate x's. I can't have x in my answer. That's like defining a word and using that word in the definition. So what I actually do is I factor it. And here, if I factor this, I get x minus 4 times x minus 1. Well, now what? Well, notice these factors are being multiplied. Let's say I have a times b, and that equals 0. What must be true? Either a equals 0 or b equals 0. Because whenever I multiply something by 0, I'm going to get 0. So if I have 1,000,000 times 0, the product is 0. So what I actually do is I set these two factors equal to 0. And here we can see I get x equals 4 and x equals 1 by solving. And that's what the graph shows me. So the 2 points are 4, 0 and 1, 0. Again, because these are points on a graph, these are x-intercepts. So let's look at these. There is no graph here. So I'm going to factor these just as I did before. Here my variables are. So if this is equal to 0, I get r and r. And so I need two factors of 48 that add up to get negative 14. So that's going to be negative 8 and negative 6. And so if I set these both equal to 0, r minus 8 is equal to 0, and r minus 6 is equal to 0. I get r is equal to 8, r is equal to 6. So I get 8 comma 0 and 6 comma 0 as my r intercepts in this case. And then for the next one, I'm going to factor this. Two factors of 20 that add up to get negative 9, or negative 4 and negative 5. So if I set each factor equal to 0, whoops, and solve, I'm going to get that x is equal to 4 and x is equal to 5. So I get 4 comma 0 and I get 5 comma 0. And that's it in terms of finding x-intercepts. So the key, no matter what type of equation you're solving for, always set y equal to 0. Make y 0, and then solve the equation. For quadratics, you have to factor. And for lines, you just solve as you would any other linear equation. Now, there is also something called the quadratic formula. There's a brief video explaining that on my website. In algebra classes, you will use the quadratic formula more. For us, we want just a very basic definition. So for the problems that you're going to have to do in this class, they're going to be nice, easy, and factorable. But just be aware that you can't always factor, and you won't always have solutions. But again, for us, for this class, you will, and you'll be able to factor.